Hello and welcome to this edition of Stats Chats. Here we're going to be talking about how to conduct a regression analysis. One way to conduct a regression analysis is to use the scatter plot function in SPSS. And when SPSS generates a scatter plot, there's an option. You can click on an icon, I think it's second or third from the right, and that will give you the line of best fit and the R-squared value. And we can see the regression equation here as well. Y equals 3.32 plus 0.34 times x. In this particular scatter plot, we're looking at how self-compassion mindfulness predicts trait emotional intelligence well-being. One thing to keep in mind is that when we're doing a regression analysis, we have one independent variable and one dependent variable. The independent variable may be called by a different name, like criterion variable, predictor variable, explanatory variable, or the manipulated variable. And the dependent variable may be called the variable on the y-axis, the predicted variable, or the outcome variable, or even in some older publications, the manifest variable. When we talk about simple linear regression, we're typically talking about one independent variable and one dependent variable. However, we might find that we conduct a regression analysis and we find that one independent variable accounts for a certain percentage of the variance, maybe 15% of the variance. But we wonder, well, what if we look at other independent variables? May these account for more of the variance? And so perhaps then we add other independent variables to this model. And this is what's called the multiple regression analysis, where we have multiple independent variables and one dependent variable. So with the multiple regression, again, we have multiple independent variables and one dependent variable. Now here we have a bunch of independent variables, one dependent variable, but we may be wondering, well, what if we put these independent variables in a particular order? Do they better predict the dependent variable? And that leads us to, we could do something called path analysis, where we look at a particular pathway. And here you can see an example from renowned marriage therapist Dr. John Gottman's research on a path analysis for stable, happy couples there. And you can see the different pathways. Each of these rectangular items includes an observed variable, and the pathway, we see the coefficients along the way as well. And these are just a few other examples of these path analyses here. And then some very interesting findings with screenshots from Dr. Gottman's work. Now, let's look at how to conduct a linear regression. So in order to conduct a linear regression, we want to open SPSS and go to Analyze. We click on Analyze, a drop-down menu pops up, and we click on Regression. Whenever we click on Regression, another drop-down menu pops up. We can click on Linear Regression. After we click on Linear Regression, a dialog box appears. In the dialog box, we're able to select our dependent variable and our independent variable. For a linear regression, we'll select one dependent variable and one independent variable. For the purposes of this example, we selected post-attachment related anxiety for the outcome variable or dependent variable, and post-test trait emotional intelligence emotionality for the independent variable. Then we click OK, and SPSS will then generate the output for this linear regression. And we get these tables here. And we can look at our R-squared value to identify that our independent variable emotionality on the emotional intelligence questionnaire accounts for 23.1% of the variance. On our dependent variable, the post-attachment related anxiety questionnaire, we see that under model summary, we see our R-squared value. We may also want to know if our model was statistically significant. We can look at the ANOVA table. We see the SIG level is 0.007, which is less than 0.05. And we look down at post-trait emotional intelligence in our coefficients table, and we can see that the significance level is 0.007, so it is statistically significant. So in an APA style write-up, we might report this as 1 unit of trait emotional intelligence factor of emotionality, and then we put in parentheses what emotionality includes. Increases, then the post-treatment attachment-related anxiety decreases by negative 1.067. You can see where we identified these values in the output from SPSS. So the R squared here on our model summary is 23%. The degrees of freedom are listed here in the ANOVA table. The coefficients significance level is listed in the table at the bottom. And we can also get our data here to inform our regression equation, which we'll talk about in more detail on another slide. And then this is one part of our APA styles results reporting, as we might say, as one unit of trait emotional intelligence factor of emotionality increases, the post-treatment attachment-related anxiety decreases by negative 1.067. And then we include Y hat, and Y hat is a point on the regression line. It's written like this Y with a little symbol looking like a hat above it. And the equation is Y equals A plus BX. So A is the intercept. So we find that here under constant 6.347. And then we plug that in, plus B, which is our slope, which is negative 1.067. So we plug that in there. And then this gives us our equation, our regression equation. Okay, so if we were going to do multiple regression, we go through the same process that we discussed previously. So if we go back, let's see, to that slide, we go to analyze, regression, then linear regression. Then we select our dependent variable, but we select multiple independent variables for multiple regression. So here I think we selected suffering as well as another variable. And we looked at suffering and personal distress, and we found these items were statistically significant. The model was significance P is less than 0.01. Here we can look at the significance level. The R squared was 31%. So this is how much our independent variable explains our dependent variable. So we'd say the model is good or statistically significant. Okay, so again, this is another example, but these are the key things we want to look at in our output. We want to indicate whether the model was statistically significant and report the F value from our ANOVA table, as well as the P value and the degrees of freedom. And we can also calculate what Y hat, which in this case is self-kindness, the self-compassion scale self-kindness scores, would be based on any given X value from our particular assessment, which we were using a trait emotional intelligence questionnaire. And so we could look at a particular value there and get our Y hat value. All right, so pretty exciting stuff. A regression allows us to move into prediction and building models. I hope you have enjoyed this edition of Stats Chats, and I hope this gives you some concepts to contemplate. Until next time, may God bless your work.